Okay, so this unit's called Bitmap and Vector. And the first thing I want to do is establish what a bitmap graphic is. Any of you encountered what a bitmap graphic is? Can you tell me? Right, okay. Right, here's the first important point, right? A bitmap image is made up of pixels. Okay? That's crucial. Right? So there's your first thing you've learned, right? The second thing, vector images. What's the difference between a bitmap and a vector? What is a vector image? Right, good. So vectors are shapes, but bitmaps can be shapes too, can't they? Aye, you're in the outlines. But can we come up with a definition? It could be. Right, a vector image uses mathematical coordinates to plot points. Right, now here's the difference. If you have a bitmap image, every single dot is stored in the file. If you have a vector, it will say, for example, it's a circle. It will store the radius of the circle and the center point of the circle and the color of the circle. Right, and then it's not as much. So you can have a circle that's 800 pixels wide in a bitmap, but in the vector, it gives it instructions. This is a circle, it's 800 pixels wide. So you don't store every single pixel. to cut a long story short, excuse me, bitmaps are excellent for storing photographic images and photoreal images, right? Vectors are excellent for storing, as John said, logos, right? Now here's the thing, if you, say you get asked to design a website for somebody, right? And hopefully that's why you're on this course. You want to eventually go and either build websites or design interactive media products, right? So, Big Mick the Baker wants his a website done, okay? So, you go and you design a logo for him, right? And you chuck that into the cost as well, by the way, right? You don't do it for free. What, what graphical format do you store it in, and why? Why? You put your head above the parapet. Right. It can be smaller, yes, right? But I'm going to throw a curveball at you here. You can't put vectors on websites because the file format doesn't get displayed in HTML. You can store in bitmaps, but your original answer was right. So where are we going here? Right, here's the thing. Right, brilliant. So we can do it in vector, right? Now the reason you would do the original one in vector is because you can resize it without losing the quality. So Big Mick the Baker goes worldwide, right? And he's saying, I've got a 100-foot billboard in Times Square. Can I use the image you've created for me? And you say, of course you can. However, if you have designed that in Bitmap and you stretch it to 100 feet, it's going to look rubbish. Big Mick, the baker's company, folds. Right? Just like his pastry and his eggs. Right? So, company goes to the wall because of your rubbish logo. However, your logo wasn't rubbish. What you should always do, and for your own benefit as well, if you are designing a logo for a new company or whatever it may be, design the original in Illustrator. Save it as a vector. Because then, when you get the phone call, I need to use a 100-foot billboard in Times Square, there's the vector file. And the printers, or whatever it may be, can just stretch it and not lose quality. Because it's only coordinates. So they just change the coordinates, don't lose the quality. If it's made up of wee dots, and they stretch it, it looks terrible. So there's the difference between the two. Alright. Right. The idea here is that bitmap, we'll concentrate on bitmaps just now, right? Bitmap images It's an illusion because it's just dots joined together to make it look like a picture to us. Right? If you go straight up to some images that are lots of wee dots, they don't look like the image. You back away and they do. Right, okay, so bitmaps in here are used when lifelike or detailed graphics are required. Bitmaps can be images of real life subjects, which I've said, computer generated images, and if you've taken pictures with a camera phone, the chances are that'll be a JPEG. I'll come on to GIFs, JPEGs, and PNGs a wee at a time, right? You can grade the quality of your image by how many bits it is, right? The higher the bit rate in an image, the higher maybe the color could be. All right. Um, right. Let's see. Okay, we'll talk about bits. So each pixel can contain anything between 8 to 48 bits of color detail. The higher amount of bits supplied gives a wider range of colors. To summarize, pixels and properties and the properties of the reason that lifelike computer-generated graphics and detailed graphics are created using bitmaps. Photos are stored as bitmaps so they can be edited and retouched by using Photoshop, etc. Other pieces of software are available. And I've said the higher the color depth and the higher the resolution, the better the quality should be, right? But here's the problem. The higher the bitrate and the more pixels you've got in your image, what also gets bigger? The file size. Why? As web developers, as you guys are all going to be, right? Why is that crucial? Why does the file size come into this? Load times, right? Now, I've had a bit of a shift in ideas down the years, right? This is a big issue. Who remembers dial-up broadband? Right. All of you? Really? Right. So what dial-up was all we had in the olden days, right? What was the what was the downside of dial-up broadband? Or dial-up modes? Aye, aye. In the days when house phones still rang, that would disconnect you, right? What else was the major? I was going to say downside. Right, so at 2 ages, right? The communication speed was very slow. I think it was 56 kilobits per second, which is right. And by the way, that's kilobits, not kilobytes, right? So very slow. So when you were building a website, there was a statistic at the time. I think it was you had 10 seconds for a page to load up. People would go elsewhere. You're lucky probably if you've got 2 seconds now, right? So the as time went on, the internet connections getting used got faster and faster. There's a website where you can actually look at the statistics for this, right? So at that point, did file size become less important? Probably did, to be quite honest with you, right? So you could get a bit lazy with your compression, right? Then what happened in the internet industry or the online? What was the shift? Yeah, what happened? Who's been on the World Wide Web this morning? Who's been online on their phone this morning? Oh, right. So there's a difference. So people who we've not got the internet in here this morning, right? So who has access to the World Wide Web using their computer this morning? Not one of you, right? On, you've been busy, right? Um, so with your if you go online using your phone now, if like me, you've got data caps with your phone company, right? So say you go into a website and it's got an image on it that's 500 meg, which is ridiculous, right? But what happens? It takes forever for a start, but use also it eats up your data. So we now again we are back to square one. It's very important that we keep file sizes down to a minimum, right? How do we do that? Well, we use different forms of compression. Compression is important because, well, for two reasons. Say I give you a task this morning, right? I may pick on Jordan and just say he has to take a bouncy castle to the top of the campsies. We will stand with binoculars and watch him taking the bouncy castle to the top of the campsies. How can he go about taking a bouncy castle to the top of the campsies? Get a bus. Takes a straight route, okay? Right, so talk to me here. Let's help him. Sorry? Say it again, slower. Right, so that's the point. The castle has to be deflated before we take it up. Right, so it has to be small. Why does it have to be small? Right, now funnily enough, you'd said about going on the bus, right? But imagine trying to go on a bus with a bouncy castle, right? It's not going to happen. So you need to compress that bouncy castle before you take it, right? And then at the other end, you need to decompress it because, well, how are you going to play in the bouncy castle at the top of the council? It's not popped up. But what you've got to do is compress something before you move it, and then he decides he's going to keep it in his house when he's done with it. What does he have to do with that? He has to compress it. So for storage and for transport, you have to compress things. Agreed? Right. It's the same with images. So JPEG is the majority of you will have used mobile phones and taken photographs. I'm not interested in what of, right? But when you've taken that, it's stored on your phone, or you may be sending it across the internet to your pal, right? So you want it to be compressed for storage, and you want it to be compressed for transport. Agreed? JPEG allows you to do that. JPEG has some strengths. These will give you marks in your exam, what I'm about to tell you, right? JPEGs can hold 16.7 million colours, right? That's a lot of colours, okay? Um, it supports 24-bit colour, right? But it doesn't allow for it doesn't have transparency. You never hear about somebody talking about an animated JPEG either, do you? You've been talking about animated GIFs, yeah? Come to that in a minute. So, JPEGs are excellent for photographs, and they make the file very, very small. Come to that in a wee second, right? Because that also applies to MP3s, right? So you can choose in JPEG how compressed you want your image to be. There's always a trade-off, right? If you choose really high compression, right, then the image quality will go down a wee bit. So you've got to get a balance. Do you want it to be an incredibly clear, clean image with a a high file size, or do you want it to be a reasonably low quality image with a very low file size, right? So you've got to make that judgment yourself when you're saving it from Photoshop, right? Um, Right, you had asked me about lossless and lossy. I'll come to that after I've done the file formats, alright? JPEG has lossy compression, which I'll touch on, right? GIFs. It says it's lossless, again I'll explain in a second. GIF only supports up to 256 colours, right? However, look at that logo there. See that respect poster, right? Where it says no eating or drinking, right? Right. Promote a positive environment. So look at the smiley face, right? How many colours are used in the smiley face? Two. Right. What file format would you use? JPEG or GIF? Use a GIF. Alright. And when you're using Photoshop, you can choose and see the file size, the quality, and how long it would take to download in different connections. Right. So that's the perfect example of a GIF. Okay. Most of those posters there are perfect examples of the GIF. You'll see up in the poster up there, there's a photograph where it says Amy Smith. Underneath is a wee picture. What would the picture of Amy Smith be stored using? JPEG. Alright, it's a photograph. It's got lots of colours. Say I take a photograph of that wall as it is. Right? How many colours are on the wall? Right? I wouldn't disagree with you, but when you're taking the photograph, you've got the shadows, the light, all the different areas. If we only had one colour, if we take what you said, you wouldn't be able to represent shadow or the different grades of shadow, because you'll see the shadow of that light there. It's not just one shade of blue, it's thousands of shades of blue, just darker then becomes lighter. So a JPEG would be stored for used for taking a photo, even if it's something of one colour. Does that make sense? Because it's very rare in real life you get something that is only one colour. Do you know what I mean? Even if you take a photograph of one, like your jacket, there's two colours in your jacket, but the shadows and the lights, and you've got to take that into consideration. Okay. Right. Another file format, BMP. It's just to confuse matters, right? BMP stands for bitmap. Don't confuse that with bitmap as in bitmap vector. Right? It's just a file format. It's uncompressed. Microsoft Paint uses it, so we'll muck about with that and look and see the sizes. Okay. Then next, right? Sorry, I'll touch back on GIFs. GIFs support transparency, which can be very useful in a website if you're putting in a logo and you want the background to match up. And so GIFs support transparency, and also sorry, PNG, yeah, it does as well, right? GIFs also support animation. You've all seen daft wee animated GIFs online, yes. So they're still popular for that. A lesser known fact is that if companies, so say like Photoshop, uses GIF compression was invented by a company called CompuServe. CompuServe would bill companies like such as Adobe for using the algorithm of compression. So GIFs actually cost companies money to use. Alright, so we worth a note. What is replacing the GIF is the PNG. Okay, the PNG it can be used for simple graphics as well as photos. It's probably not as good as JPEGs for actual photos, but it can be used for them. So the PNG is like the new kid in the block, really, still compared to the other two. This one here, a TIFF. I've never actually practically used a TIFF, but it's used to exchange files between applications and platforms. Most desktop scanners can produce TIFF files, so I don't think I've ever worked with a TIFF file, right? Okay. Attributes of bitmaps, there's a photo, it talks about pixels, resolution, and colour depth. I've kind of covered that, really what I was saying there. Okay, so in that example there, there's, what's that? It's eight bits have been assigned to each pixel to represent it in that image, okay? The more bits you assign to each pixel, the more colours that it can be represented. Does that make sense? Right? Because you think about it, say you've got a 1-bit image, what can it be? Right, 1-bit image, what could you represent with a 1-bit image? What? Black or white? Right? 0 or a 1. If you can only store, say you've only got that wee box to put a number in, right? You've only got a choice. 0 is black and 1 is white. And that's it. Okay? However, with more bits, you can put in more colours. Does that make sense? Okay. This here, you'll see there that they've zoomed in. That's what would happen to Big Mick the Baker's poster in Times Square, right? It would become pixelized. Okay. Resolution. The amount of dots per inch. The higher the resolution, the more you can represent with it. If you try to represent, I'm trying to think of an example. Say you had to represent that whole poster there with 1 pixel, right? You could have a massive colour depth on it. What would it be? What would you have to choose? You've got one choice. That poster there. What colour? white, so you've got one pic. I'll go white, right, just because more in it. So 1 pixel does not represent what's going on there, does it? See, you had 4 pixels. Aye, but it's not going to represent anything very well, is it? Think back to Space Invaders. They don't really look like spaceships, do they? Right? But the higher the resolution, the more shape you can put into it. Right? The more dots you can use. Make sense? Okay. And again, the higher the resolution, the higher the file size. Right, okay, I've covered that. Right, okay. Anti-aliasing, right? This again is something that you can be asked about. Right. So you'll notice that when you scale a bitmap up, that the images of the object look more jagged. You can see this edge of the building in the images in the previous one. Um, it is known as alias ingor. No, it's not. It's known as aliasing. There should be a space in there. Look, right? Known as aliasing, more formally known as jaggies. To get rid of this, anti-aliasing can be applied to the graphics package. The graphics package below has had it applied. Color depth, and again we talked about this a wee second ago. I often go ahead of myself here. So, you've got 1 bit, we talked about, you can have 2 colours there, right? 2 bits, 4 colours, 4 bits, 16 colours. How did I work that out? Binary, have you done binary at all? Okay, so 8 bit 8-bit colour can give you 256 colours, just following on. So if you get 2 to the power 8, you can have 256 different possible colours from it. Alright, again, the higher the bit rate, the higher the file size. Okay, and on it goes. 32 bits, 16.7 million. Okay. Dithering is a phrase that will come up. Okay. Um, when you reduce the colour to 8-bit, it's known as index colour. Each colour is assigned to a number or index, a palette of up to 256 colours. The GIF format uses a colour lookup table, which is one of the reasons that file sizes can be small. So what it will do there, see if you've got an image see you've got an image with 500 colours on it, and you want to save it as a GIF. What it will do is it will try and match the colours to the colour lookup table. But obviously then it won't be quite as good, yes? But it'll be a smaller file size. And that's where the trade-off happens. Right? So if you have got a big multicoloured, millions of colours, get the colour lookup table will try and match it to the nearest one. It will never look quite as good as the original. Yeah. So it would say it's got a specific colour of red, and then the GIF doesn't store that. It will try and match it to the closest the nearest colour to it. Right. The problem with the dithering is the graphic can end up grainy, so you're getting a trade-off in quality there. Right. So original image with no dithering, and there's the dithered image. I don't know if Impero's shown that up well enough. The one on the right hasn't got as much quality. Okay. As with resolution, the higher the colour depth means larger file size. You'll have to compress the image into a JPEG. Right, lossy and lossless. Again, this will get you marks in an exam. Lossy compression, right, is JPEG. JPEG uses lossy compression, and it will throw away some information. Right? With lossless compression, it is compressed, it doesn't lose anything in the compression. GIF uses lossless compression. Okay, so it doesn't lose any quality. Yep. Makes sense? So lossy, JPEG, loses quality, GIF, lossless, doesn't lose quality. Try and keep that in your head, okay? Right, vectors. Okay, we're doing alright for time here. Right, so vectors, as I said, are completely computer generated. It could be banners, lines, diagrams, that sort of thing, right? Not photos. Vectors don't consist of pixels. Now, here's the funny thing. In terms of the way they're stored, they don't consist of pixels. Of course they don't. However, when they're displayed on your screen, what do they have to use? Pixels, right? But they're never stored like that. That's just a medium of showing it to us, okay? Vectors are easier to edit. Well, we'll see that when we try and have a go at Illustrator. The following extract from the Adobe site gives further definition of vector graphics. I've seen better definitions. Vector file formats are small. Now, these notes are a wee bit old, but for the purposes of this unit, we'll stick with what I'm about to say. A browser such as Chrome or Internet Explorer cannot display a vector graphic. Right, we'll stick with that. So a vector graphic could be an AI file, an Adobe Illustrator file, right? And it won't be displayed. However, HTML5 allows you to create vector graphics, just to confuse things. But we'll not talk about that in terms of a file. Alright, does that make sense? Okay. Can I repeat myself here? Vector graphics currently aren't widely supported by web browsers. There's only one format supported by some, and that's SVG, Scalable Vector Graphics. But you would need a plugin to use SVGs. Okay, if in web design we want to kind of stay away from plugins as much as we can, because not everyone's got them. So you don't want your whole website to be based on a plugin, right? And the user doesn't have it. That's where you start to get problems. Attributes of vector graphics. There's two there. Shapes, coordinates, and points. Now, I say to you, there's two vector graphics there. That's two representations of vector graphics. They're not really vector graphics, though, are they? Because if I stretch them, they pixelate. So it's a representation of a vector graphic. You understand? Hopefully. I'll show you the difference in Illustrator. Right, so they use coordinates, use anchor points, and you can twist it and use pen tools to manipulate the graphics. Coordinates, are you all happy with coordinates? Right, you've got X and Y coordinate, X and Y axis. X is along, so it's the first one. That's it. So that position there is 0, 0. That position there is 0 along, 10 up. That's 10 along, 10 up. All got it? Yeah. Okay. Other things that they can store is the thickness of the lines or the physical characteristics of the lines. So they can be curved. You can have strokes, or you can have there's brilliant pen tools in Illustrator that you can use. Don't know if you've seen them, no. They give a really different effect. So there's two vector lines, both with different effects. This I remember coming up, the Bezier curve, or the Bezier curve, right, whatever we want to say. The type of curve while using vectors is the Bezier curve. Most of them use the pen tool to create it. Endpoints and direction points are known as control points. Two anchor points are required to create the curve. These are known as the endpoints. By clicking and dragging, this creates direction lines, which have direction points, handles. The more you drag, the bigger the curve. Again, that's maybe when you get told to play in Illustrator, you may have seen this. I don't know. No. Illustrator, right, for a start, pleases I'm terrible at drawing, right? So my Illustrator is limited, and to be honest with you, I've not used it in a few years. But you can do quite impressive wee things with it for somebody who can't draw anyway. If you can draw, then you're probably not that impressed. But I'll show you some stuff you can do with it. Paths. When you draw a more complex vector, of lines and curves, they're known as paths. They consist of a number of anchor points. So the computer is storing the anchor points, it's not storing the pixels. Drawing packages, freeform pencil drawing tools, creating detailed paths. Pen and pencil tools are widely used in Illustrator. there's an open path, just a line, and a closed path. You can fill it in, colour it in with a paint bucket type thing. Text on a path, well, you can see there's text on a path, right? Don't need to explain that anymore. And fill colour is the colour that you use to fill in your vector graphic. Gradients, you'll come across gradients before, yes? It's really just a shading of one colour to another. You can do it in Illustrator, PowerPoint, and you can get different types of gradient fill, linear, radials, a circle, and different directions as well. You can use pattern fills for backgrounds and interfaces. Again, you can buy add-ons for Illustrator, different pens, pencils, different background fills, stuff like that. Screen-based applications. These notes are pretty old, right? Because it talks about director and authorware. Macromedia as a company doesn't even exist anymore. Macromedia were the company that invented Dreamweaver, and Adobe bought them. So Flash and Director are really, well, Flash is still getting used now and then, but not massively. If you want to incorporate vectors into a multimedia application, we have to rasterize it first. If you want to incorporate a vector into a web page, you have to convert it. This is because web browsers don't support traditional vector formats. SVG, as I say, have become more popular. Take that with a pinch of salt, this paragraph here, because as I say, it's quite old. Alright. Vector file formats. We won't spend too long on this. The two are interesting to us are AIs, the Illustrator one, and the scalable vector graphics. It's an open standard, and it means that no company owns it. So it's trying to get vector graphics on the World Wide Web. We'll have a look at HTML5 and where vector graphics sit on it. I'm not entirely sure. Flash used to, they still do, right? Flash would use something called a shockwave file, right? Flash was massively popular. It supports vector animation, and you get very small file formats. Compression. Okay, I covered compression, I think, with you. Talking about storage and right, there's lossy and lossless. I had to write a 2000 word essay on the Lempel Ziff Welsh compression method at uni once. Right, they're just the different mathematical algorithms used to get the compressions. Okay. Codecs. You used to hear a lot more about codecs. Have you heard about codecs? No. It's a compression decompression, right? For some movie formats, you need a codec in order to play it, because it needs to be compressed to store it and decompressed to play it, and that's what codec stands for. Again, I don't think anything like that comes up in your exam, right? So that's why we talked about lossless compression. There's a process of compressing text. Uncompressed data, hello Sandra. Compressed data, it's missed out the vowels, and decompressed brings the vowels back in. So no data's lost in there. Again, I've kind of spoken about that. Lossy compression, right? MP3 uses lossy compression as well. Anything that it thinks is undetectable to the human ear, it will just bin it. Okay? We'll chuck it away. Lossy is only effective for media elements that can still work or still look good without the data, right? Because there's no point in it binning data that's going to affect how the actual final product looks. So lossy compression, as much as it loses information, not detectable to the human eye, or in MP3 case, the human ear. That's the plan. Okay. Now I'll give you these notes to have a look at, guys. All right. Let's see if anything else I want to cover. Metagraphics are a combination of bitmap and vector. They aren't as widely used. An example would be a metagraphic would be a map of a photo showing an aerial view of a town where landmarks are highlighted using vector text and graphics such as arrows. Okay, so that would be meta graphics. Again, have a wee read through. Animated GIFs, you've all seen them. See when you're bored in a class, not that I've quite lost you yet, but we're getting there. Right, Have you ever sat and you had a jotter and you drew the wee stick man, right? And you made him dance about? You ever done it? You've lived, right? That was how we used to entertain ourselves in the Victorian days, right? You would put a wee, you could draw a stick man, and then that you'd be like, and the next page you'd wave, and then you would flick the book, and you would see him dancing about. But he's not really dancing about. He's not really a real man, right? But the issue there is it's the illusion of movement, and that's all videos are, by the way. An illusion of movement, right? It's tricking your eye into thinking it's really happening in front of you. That's what video is. Um, animations online, 12 or 24 frames per second are tend to be used. Again, some of this is kind of like nudged towards um, Flash. Right, couple of things. When do you use graphics in a? You're doing user interface design, yeah. Right, so you're designing an interface. When do you choose to use graphics? When do you? Why would you put a graphic in something? Okay, let's consider that poster again. This respect poster here, right? What are they using graphics for? Right? I mean, they could attract your eye to tell you to go on your phone, eat your food, and sit with a smiley face. Right? So on their own, it doesn't mean much, but it's to draw attention to it, and the text is underneath, right? So use graphics to back up what you're trying to put across. Um, Also consider your network you're working on, right? See for whatever reason you're working on a website for partially sighted people. How do you go with that? How do you design the site? Do you use all images? Wait, why not? Right, so you use alt tags. But what you should also have there is you should have a website that can be accessed by somebody who has sight difficulties and maybe that reads the content to them. So you would never only depend on. Aye. Yeah, yeah. Right, so it's for everyone. Um, you want to make a world wide web that everyone can use for two reasons, right? The first is quite a noble reason. It means that it's fair. Somebody who has sight difficulties or special needs should have the same experience as us online. Agreed, right? And that's I would say is the main reason. The second, and don't I'm using this as an example. I'm not really that mercenary, right? There's legal problems, right? There's moral and ethical reasons behind why we should be doing this, right? New buildings should be built with ramps and lifts and so on. What is the second more cynical reason of why people with sight difficulties should be able to access a website you've built? Larger audience means, right? Now that's not the, you know, it is sadly it is. Now, as I said, the main reason should be, that it comes into it for good reasons. But listen. You don't always build websites for nice people, right? And the only reason they may care that their site is accessible is A, they don't get fined, and B, they get more money. And they don't really, you know what I mean? So, so for whatever reason, make sure your site is accessible and use your graphics properly. Text. Well, I don't really know if I have to talk about text in terms of why you would use it. One thing says we recall 10% of what we read, 20% of what we see, and 30% of both what we both see and hear. Now, that's why I'm recording this, right? Because, alright, I can see that the attention starts to drift, and usually in a class by now, I would have stopped talking. But this might be the only maybe the only time I get you. So I'm just trying to pile the information on you and also record it so that you guys can use this when it comes to exam time as well. Alright? Or if you're struggling to sleep at night. Um, so, but it's there, so it's an audio thing, it's a visual thing, and I'm trying to get you to interact as well. Animated graphics. Well, where would you use animation in a website? And it can be used quite effectively. You'd use a diagram to show something working good. When else? I've shown some of you last year not to go on your phone. Right? I've shown some of you last year. What do we do when we try to outdo a menu? You could do rollovers and colour changes and animations when they go over a button to tell the user they're over a button because it helps them navigate. Now you're trying to make this easy, seamless site. So animation could be simple, something changing colour. I don't know if you've looked at jQuery yet. You can do animation with jQuery. It makes it more interesting. Okay, sound. In terms of web design, I hate uninvited sound on a website. I hate it, and it's something that seems to be coming back into play. It died off because it was kind of considered bad form. It's back and it's annoying. But where can we use sound in a multimedia process? Well, narration could be excellent for something. All right. Again, it could help somebody who can't maybe read the information for whatever reason it may be. Video should be used sparingly. Video sizes are huge, or can be huge. So how things are compressed can be interesting as well. Again, video has changed so much. It says there a 10-minute video can cost 5,000 to produce. Well, look at how technology's moved on the last few years. You know what I mean? It's so different. Right. Color models. Have you covered color models in user interface design? Right, very quickly I'll take you through this, right, because I think you cover this in another module. Right, so you've got different colour models. You've got grayscale, RGB, which mixes red, green and blue. You done it? RGB as a mixture of light. CMYK is the printing of information, alright? You do get slight, the important thing for your graphics, and again, see if you're ever designing something for screen, it will look different printed because the print uses CMYK to print it out, and the light mixture on the monitor is RGB. And that might seem a very trivial point, but see if you're designing a brand, or you've just got to work in the discrepancies between the two models. Right? I think Photoshop covers it for you now, but you just got to watch because it might be very important to a company that the colour is identical to the eye and on the monitor, and identical to the eye on printed paper as well. All right. Um, just going back through this, by the way, you realise how quickly things change because a lot of this is dated. Right, RGB model. There's that number again, 255, and that's all down to binary, right? If you go 255, 255, 255, you're mixing every colour available to you, red, green, and blue, right? You mix red, green, and blue, but zero counts. That's why it's 255. The first digit, so you're one down. You'll see that in loops as well in programming, right? So if we mix 255, 255, 255, say I bring in a red paint tin, a green paint tin, and a blue paint tin, and we pour it into a big bucket. What colour are we gonna get? Probably brownish, messy sludge, right? However, with this, we're getting white because you're mixing light. You're not mixing paint. That's why you get the difference. All right. If you mix no light at all, you get black. If you go all red and all blue, you get cyan. Sorry, I think that's wrong. I think red and blue gives you magenta. Anyway, you don't get asked with that. CMYK is the print model, alright? And the K, so see cyan, I think cyan, yellow, magenta, and black is the K. And they don't use blue. Well, because B is used for blue in colour models. So there you go. And that shows you how the RGB colour model works. Red and blue gives you magenta. There you go. Alright. Colour wheel. Have you seen Adobe Cooler? Have you been shown that? Aye, that's quite a good site. Maybe, aye. And that's the colour wheel. I'll show you Cooler for that as well. This website, the idea of a web safe palette is kind of gone. I don't think there's any question to test on it. It used to be that you'd have 256 safe web colours. The reason it was safe is because you knew if you created like that, it would display that in any browser. Right, but I think that's kind of there's more colours than that now. And thankfully we are at the end of those notes. Now, I have not exhaustively covered them, right? And I would like you guys to go and have a read at them. But that's the gist of the theory for the module. Okay. All done in 45 minutes. Okay. So I'll stop recording that.